how to draw an activity on arrow network diagram. Activity: any process which consumes time or resource and has a definite beginning and end is called an activity. An activity is denoted by an arrow. The description of the activity will be represented on the top of the arrow, and the duration of the activity will be represented at the bottom of the arrow. Event: the beginning and completion of any activity is termed as an event. It indicates a particular instant of time at which some specific milestone has been achieved. An event neither consumes any time or resource by itself. An event is denoted by a node. Types of event. Tail event: an event which marks the beginning of an activity is called as a tail event. Here in the example, we have an activity A for which we have an initial event which is starting before the activity A has been started. The event is 1. Therefore, event number 1 is a tail event for activity A. Head event: an event which marks the completion of an activity is called as a tail event. Here in the example, after the completion of activity A, we are going to mark with an event which is event number 2. Therefore, event number 2 is a head event for activity A. Dual role event: an event which acts as a tail event for some activities and head event for some other activity is called as a dual role event. Now, in the example, we have activity B which is following activity A, and now we have 3 events: event 1, event 2 and event 3. Now if we look closely here, event number 2, it acts as an head event for activity A, whereas for activity B, event number 2 acts as a tail event. Therefore, event number 2 is playing a dual role event, since it is acting as an head event for activity A and tail event for activity B. Burst event: an event from which a number of activities emerge is called as a burst event. Here in the example, we can see from event number 2 we have activities B, C and D that are emerging out. Therefore, event number 2 is a burst event. Merge event: an event to which a number of activities converge is called as a merge event. In the example, we can see activities E, F and G are merging towards event number 6. Therefore, event number 6 is a merge event. Now let's look into the rules for drawing network diagram. There must be only one initial node in a network. The initial node must have only outgoing arrows. An event cannot occur until all activities leading to it are completed. No activities can start until its tail event has occurred. All constraints and interdependencies should be shown properly in the network by use of appropriate dummies or dummy activities. It is the usual practice to show the time flow from left side to right side. An event occurring twice, that is, network looping, is not permitted. And there must be only one final node in a network. Now let's look into an example on how to draw a network diagram for the given activity and the predecessor relationship. We have activities on the left hand side of the table and the predecessor relationship for the given activities on the right hand side. Now let's see how to draw the network diagram for the given activity predecessor relation. As mentioned in the rules for drawing the network diagram, always we have to start with one single initial event. Now from the table we can see activity A does not have any predecessor, whereas for all the remaining activities there are one or the other predecessors. Therefore, activity A is our first activity. Once the activity A is complete, we have to close the activity using an event. Now let's move on to next activities. From the table we can see for activity B and activity C, A is the predecessor. That means after completion of activity A, both activity B and activity C are going to begin. Now we'll see how to draw the activity B and activity C. After completion of activity A, activity B is going to start. Once the activity B is completed, we have to show with the help of an event. Similarly, we have to draw activity C after completion of activity A, and the completion of activity C has to be shown using an event. Now we can clearly see activity B and activity C are parallel activities. Therefore, we can interchange these activities something like this. Either you can have activity B on top and activity C at the bottom, or we can have activity B at the bottom and activity C at the top. So this representation can be done only when there are parallel activities from the given single predecessor activity. Next, we'll move on to activity D. For activity D, activity B is the predecessor. That means after completion of activity B, activity D is going to start, which can be shown something like this. We have activity D starting after completion of activity B. Once activity D is completed, we have to represent the completion of activity D using an event. Now let's move on to activity E. From the table we can see for activity E to start, activity C has to be completed, which can be represented in the network diagram similar to this. We have activity E which is starting after activity C is completed, and the completion of activity E should be shown with the help of an event. Now let's move on to the last activity. Activity F, the predecessors are activity D and activity E. Whereas in our network diagram we can clearly see activity D is completing at some time and activity E is completing at some other time. Therefore, it becomes very difficult for us to draw activity F for the drawn network diagram. So in order to have activity F and the predecessors for activity F to be D and E, we have to merge activity D and activity E. Now from here we can draw activity F and we can show the completion of activity F using an event. So this is how we have to draw the network diagram for the given activity predecessor. Now let's see how do we number the events. The numbering of events is followed by a rule called as Fulkerson rule. Now let's see what does this Fulkerson rule states. There is a single initial event in a network diagram. The initial event will have arrows coming out of it. The number the initial event as 1. Neglect all the arrows emerging out of the initial event which was numbered 1. Doing so will apparently provide one or more new initial events. Number these apparently produced new initial events as 2, 3, 4, etc. Again, neglect all the emerging arrows from these newly numbered events. This will create few more initial events. Follow step 3 and continue this operation until the last event is reached. How can we number the events for the given network using the Fulkerson rule? As per the rules, our entire network diagram starts with an initial event, and this initial event has to be numbered 1. From this event number 1, we have to mark all the outgoing activities. In the network, we have only one outgoing activity, which is activity A. Once we have traced activity A, we have to see which is the next event that is occurring. So we have only one event after completion of activity A. Therefore, we are going to number this event as event number 2. Now we will move on to event number 2. From event number 2, we have two activities, activity B and activity C are starting. So we are going to trace both these activities. By tracing these two activities, we are going to have two events. And please note here, these two activities are parallel activities. Therefore, we can number the event occurring after activity B as 3 and the event occurring after activity C as 4. Or we can interchange these numbers and have the activity emerging after the event emerging after activity C as number 3 and event after activity B as event number 4. This is because the activities B and C are parallel activities. Now, after event 2 is completed, we have to move to the next higher event, that is event number 3. This is very important. We cannot skip any of the numbers of the events. After event 2, we have to move to event number 3. You cannot move to event 4 unless we have completed event number 3. Therefore, now we will move on to event number 3. From event number 3, we have only one activity that is starting, that is activity D. Now we are going to trace activity D. Now we have to move to event number 4. From event number 4, we have only one activity that is starting, which is activity E. Now we are going to trace activity E. Now we are now traced both the activities. Now we can number our next event, which will be event number 5. After completion of event 4, now we will move on to event 5. From event 5, we have only one activity that is starting, which is activity F. Now we will trace activity F, and we have reached the last event, which can be numbered as event number 6. And this is how we number the events for the given network using the Fulkerson rule. Now let's look into one more example on how to draw a network diagram for the given activity predecessor relationship. As usual, according to the rule, for any given network, we have to start with one single initial event. Now from the table, we can see activity A and activity B do not have any predecessor. That means these two are parallel activities, and they are the one which are going to start first. And also, since there are two activities which are starting at first, we cannot have two initial events. So this is very important. Even though there are multiple number of activities which will be starting first, we need to always start with one single initial event. Therefore, from one single initial event, I have activity A and I have activity B. Now let's move on to the next activity. Now I am skipping activity C, because for activity C I have predecessors as activity B and activity D. Now we can see from the network diagram, I do not have activity D yet. Therefore, I cannot represent activity C in the network diagram at this point. Therefore, I will move on to activity D and activity E. Now we can see from the table, activity D and activity E has a common predecessor, which is activity A. That is, after completion of activity A, my activity D and activity E are going to start, and these two activities are parallel activities. Now I will be drawing activity D and activity E. Now we will move on to the next activity, which is activity C. Now I can see from my network diagram, I have both activity B as well as activity D. But in order to draw activity C, I need to have the predecessor B as well as C. Whereas in the network, I have activity D which is completing at some other time. So in order to get B and D as the predecessor, I need to erase activity D and draw something like this. Now you can see I can draw my activity C, for which I have activity B as well as activity D as the predecessor. So these minor adjustments has to be done in the network diagram in order to get the proper relationship between the activities. Now we'll move on to the next activity, which is activity F and activity H. We can clearly see from the table, for both activity F and activity H, we have activity C as the predecessor. That means after completion of activity C, I can draw two parallel activities, which is F and H. Now let's see how to represent activity F and activity H. I have activity F and I have activity H. Now let's move on to the next activity, which is activity G. For activity G, F is the predecessor. That is, after completion of activity F, I have activity G. Now you could wonder why I have merged activity E and activity G. For this, we have to look into the table. In the table, we can clearly see for activity I have activity E and activity G as the predecessor. Therefore, I have merged activity G and activity E in order to get activity I. Also, I have merged activity I and activity H. This is because these two are the last activities, and in the network you can have only one final event. Therefore, you cannot have two events at the end. In order to avoid that, I have merged activity H and activity I. So this is how to draw the network diagram for the given activity predecessor relation. Now we'll see how to number the events. As per the rules, using the Fulkerson rule, always the initial node or the initial event of the network has to be numbered as 1. Now from this initial node or the initial event, we have to see which are all the outgoing activities. Now we will trace the outgoing activities from event 1. We have two activities, that is activity A and activity B. After tracing activity A and activity B, now we'll mark which events have been completed. So in order to mark the events which is completed, we have to consider the event and see if all the incoming activities have been traced or not. From the network, you can clearly see the event after activity A is been completely traced. That is, there's only one incoming activity for the event after activity A, whereas for the event after activity B, there are two incoming activities, that is activity B and activity D, and activity D is still not traced. Therefore, I cannot number the event which is after activity B, whereas I can number the event which is activity A, since there is only one incoming activity and that incoming activity is being traced. Therefore, I will mark the event after activity activity A as event number 2. Now from event 1, I will move on to event number 2. From event number 2, I have two activities that are starting, that is activity D and activity E. Now we can clearly see which one to number first. The event after activity B and activity D is totally been traced. Therefore, I can number that event as event number 3, whereas the event after activity E cannot be numbered since there is one activity G which is not being traced. Therefore, I can only number the event 3, which is after activity B and activity D. Now we'll move on to the next event, which is event number 3. From event 3, I have only one activities, that is emerging, which is activity C, which we are going to trace it, and the event after activity C can be numbered as event number 4. Now we'll move on to the next event, which is event 4. From event 4, we have two activities that are emerging, activity F and activity H. Now I can number only the event which is after activity F. That is because the event after activity H, there is one more activity which is activity I, which is not been traced. Therefore, I can number the event after activity F as 5. Now we will move on to the next event, which is event 5. From event 5, I have only one activity that is emerging, which is activity G. And now I can number the event after activity G, since both the incoming activities for that event has been traced. That is, activity G and activity E both have been traced. Therefore, I can number this event as event number 6. Now we'll move on to event 6. From event 6, I have only one activity, which is activity I, which will be tracing it, and now that is the last event, which can be numbered as event number 7. And this is how we can number the events for this network using Fulkerson rule. Thank you.